everybody. Welcome all to the session of gas market strategies and process optimization. So I'm very happy and pleased to chair this session, and I'm planning to learn a little bit from our esteemed speakers on what could be the new technologies, how could we approach the markets, and also see how we can do some process optimizations with the case studies. So with this brief, I welcome Ms. Isabella to start the first session as a speaker. Please.
Hi everyone, my name is Isabella. I'm oil and gas engineering. I work at PetroReconcavo. It's a oil and gas onshore company in Brazil. And today I'm talking about the opening of the gas market in Brazil. So let's start. Yeah. So, first of all, in Brazil, the market was completely vertical, controlled by a single company, Petrobras. I think everyone knows Petrobras is the largest company in Brazil, and Petrobras produces around 2.9 million BOE per day and represents around 80% of Brazil's productions. Petrobras was responsible for production, gathering, processing, transportation, distribution, and market. Petrobras used to responsible for LNG and importation and for all the productions. Petrobras used to buy all the Brazilians independent producers who doesn't have access for midstream infrastructure and then to sell to the market. But after the oil and the market, the gas, Petrobras is not now the only company to do that. So now I'm talking about the background evolution of the natural gas market and how is this start? How is the evolution for opening the gas market? So first of all, in 2009, and it was the approval of the first gas law, and this law mentioned about they use the transportation part, but doesn't mention anything about the midstream infrastructure. So the independent company doesn't have access for midstream infrastructure. Passes that years, in 2017 to 2022, it was the Petrobras investment program. It was on progress. So that program, it was when Petrobras started to sell all your production, not all, part of your production, onshore and offshore production, and part of your pipelines transportation. And this program, it was really important and fundamental to kickstart later the new gas law. So in 2021, the new gas law, it was approved, and the law say it's now all the companies, the independent producers, start to sell your gas directly for the market. And the law, it was a landmark to Brazil energy. And in 2021, in the final of 2021, the independent producers, it's possible to sign the first contract of processing and pipeline transportation and flow lines. So in 2022, the new gas market, it's open, and all the independent producers, it's possible to sell your production directly for the market. This is really important take the market more competitive and more flexible. So, and this slide. It's the advances and the benefits and how PetroReconcavo works. How it's our model before the gas approved. So first of all, PetroReconcavo, as I said, it's an onshore oil and gas company. We have more than 20 years on the market producers. We are located in two states of Brazil, Bahia and Rio Grande do Norte. And we produces around 1.7 cubic meters per day. And PetroReconcavo, after the law approved, hired the pipeline and the processing use the midstream infrastructure from other companies as Petrobras. And since 2022, PetroReconcavo have to hire the midstream infrastructure from that producers, and then hired the transportation. And after all of this, it's possible to sell your production from the market. So nowadays, we have more than 15 gas sales agreements and divided by local distributions in Brazil, free market, and other company. This is really important to see how the market, how it's the benefits for the market. Because nowadays it's possible you sell your production directly for local companies, and if it's possible you can sell this for other producers. So this is the market is more competitive and flexible with that. And it's not all the producers sells just for Petrobras. So it's really better than before. So here I'm talking about a little bit for the Brazilian productions. The national productions is 140 million cubic meters per day. And part of these productions, 50% of them, is reinjection. And most of the part, it's from pre-sal. It's a huge part from the productions, and 38% is gas market. So 38% we can sell it for the market because it's possible we use the infrastructure, and 12% it's consumptions and flare. As you can see on the chart, we can see in 10 years all the Brazilian productions could duplicate. This is really good for us because we have all the energy. These energies comes principal for pre-sal, but it's a big problem because we need more infrastructure. So nowadays, with our productions, we have to reinjection 50%. So in 10 years, if you don't invest more in infrastructure, probably you have to reinjection more. So it's really important to invest more in midstream infrastructure. And here I'm talking about a little bit the depth of midstream infrastructure. So in Brazil, we have 9.3 thousand kilometers of transport pipeline. Comparing to USA and Europe, in USA they have 500,000 of kilometers of transport pipeline, and in Europe they have 200,000 kilometers transport pipeline. So in Brazil we are really small than there, and we just have 2.2 1,000 kilometers of gathering flow lines, just 14 natural gas processing units, and 5 LGN terminals. So, as all these reasons, it's really necessary and fundamental we invest more in midstream infrastructure because we have this energy, so we need to this infrastructure to sell the gas and to improve our energy. So, so this is my conclusion and the results and all the benefits because of the gas opening, the gas market opening. So first of all, it's the legislation and regulation now that allows new players. So because of the law, change the legislation and the regulation, so there is more players allowed. Now it's 200 authorized companies to sell their gas directly from the market. And the government remove of tax barriers, so it's really important to kickstart and to implement this. The market's more competitive and more flexible. As you can see at the chart, 17% reduce the prices. So comparing in 2022, when it's just Petrobras, when the other independent companies start at the market, the price reduce in 17%. So it's really good for the companies. And in the same time, it's really good for the population because the price reduce for the company and in the same time reduce for the Brazilian population because the molecular it's better monetization. With that, it's more investment attraction, and as I said, it's really important we have that. It's lower environmental impact because gas it's natural energy, and economic growth because with all of these we have more job creations, increased taxes, and less royalties. So that's it. Thanks for the time. If you have any questions, I'm available.
Yeah, thanks a lot. So, in the interest of the time, we'll take questions depending on time at the end of the session, and I request all the speakers to be available to that. Thanks a lot. So next, we'll be inviting the next speaker from the ONGC Uran plant.
Good evening, everyone. Good evening, respected chair and my fellow speakers. The topic of my presentation is the improvement to enhance recovery of value-added products, mainly LPG and naphtha, in gas processing plant of ONGC Uran. So the main objective of our presentation was, and it's a real study. First, what we did, we actually calculated how much potential is present in our gas processing. We have around 9.5 million gas processing is ongoing in Uran plant, and we have 4 different gas streams. So we did the analysis of all the streams, that how much liquefaction can be done, means how much C3 and above hydrocarbons can be condensed to be produced as LPG and naphtha. Secondly, what we did, we actually studied how much heavier hydrocarbons are sleeping into lean gas. Means we are paying the price of lean gas, and at the same time the heavier hydrocarbons are getting slipped into it. So we are not getting any value of it. And the third point, what we did, we actually studied the whole plant from where intermittent and continuous flarings are taking place, and we actually did some process changes so that we can reduce the flaring and actually achieve zero flaring in our plant. So before talking about this slide, I would like to actually introduce our Uran plant is very old. If we talk about our LPG plants, it dates back to around 1980, and our LPG 3 plant, it is comparatively new. It's commissioned in 2013. So the efficiency of our old LPG plants are very low. Any new upgradation at this point of time, it will take a considerable amount of time to get that changed. So we have to do whatever we had in our hands. So we worked on it. Now, if I talk about this analysis, you can clearly see that if I can condense all the C3 and above in the gas, then I can produce around 1568 tons of value added product per day. But what we were actually getting around 1400 to 1500 metric tons of web. So it clearly indicated that there was a huge potential that where we can maximize our production. And I actually take this opportunity to thank our plant manager and our head operation, because they made a separate team for that. Because earlier what we were doing, we were talking about increasing the production, but the efforts were all scattered. Nobody was working, focused on it. So a separate team was made, and they were told that you have to increase the production and do something about it. So the all efforts were getting concentrated. Now we can clearly see the lean gas composition, the earlier lean gas composition of our plant. And here you can see that C3 and C4 and presence of NC4 means all these can, if I calculate it, it is around 218 tons, means 218 tons of web, and it is actually slipping into lean gas. So our target was how to reduce that slippage. And the third point was flared gas. So whatever is flared, it is all lost. So our target was flaring should be zero. Means we should strive for zero flaring. Now, how to stop the slippage of heavier hydrocarbons in lean gas? So if I talk about Uran plant has one ethane propane recovery unit. And ethane propane recovery unit, it is the last unit in the gas processing stream. So if I want to stop slipping of heavier hydrocarbons in lean gas, this is my last stop. Here it is, I can do something. But last year, due to some instruction of ministry, the C2 C3 plant is currently operating in C3 mode. Means we are not recovering C2, we were only recovering propane and some amount of C4. So we studied the plant again, that what can be done so that whatever slippage is happening, that can be stopped. So as you can see in the diagram, the second stage vapor, which is termed as SSV, this is the feed of ethane propane recovery unit. Means you can say whatever vapors that are coming from LPG plants, means whatever vapors which are not condensed in LPG plants, that are the feed of ethane propane recovery unit. So these vapors, now if I will go to the next slide, here you can see the composition of SSV of different LPG plants. So the LPG2 plant SSV mainly contains C3, C4, and C4. So these hydrocarbons need to be condensed completely, or you can say close to 100%, so that I can stop the slippage of heavier hydrocarbons in lean gas. And similarly is the figures of LPG3 plant, which is comparatively new. So the efficiency is better, and that's why the contents of heavier hydrocarbons are less in LPG3 plant. This is one systematic diagram, you can say representation of EPRU plant. What are the processes that are happening? So the dark blue ones, where FSL and SSL are written, these are the first liquids, the first condensed liquid that I am getting in EPRU plant. So our target was how to change the process so that maximum C3 and C4 can be condensed here, because once it goes to the demethanizer column, you cannot recover it. Either it will leave as lean gas, or if you are very good at process, then you will get it as C3, C4 liquid from the bottom of the column. So we targeted that maximum amount of heavier hydrocarbon should be condensed in the first stage liquid or second stage liquid itself. So we did some process changes, and we are having number of cold box in EPRU. So we diverted some streams and actually achieved that we are getting C3 and C4 condensed in our FSL and SSL. Now, these are the two main modifications that we did in our plant. The first one is we condensed the FSL and SSL liquids, and we diverted this liquid back to the LPG plant. So by this process, whatever heavier hydrocarbons were slipping into lean gas, they were again diverted back to the LPG plant, and they added to our production. You can clearly see we calculated for 8 MMSCMD of gas, and LPG production increased with 88 tons. Now in stage 2, what we did, in our earlier SOP, we were running only one lean gas compressor in EPRU. So we were operating with around 125 MMSCMD, 125 KSMD gas means you can say 125 kilo standard meter cube of gas. Now we started another lean gas, and we increased our feed so that we can take SSV from LPG3 plant also. Because in our plant, if you will not process this SSV in EPRU plant, all the SSV will go back to consumer. Means all the SSV will go back in consumer header, it will go to GAIL, and you will get the price of gas only. So we started another lean gas compressor, we changed the column pressure, and we did some other modifications so that we can take maximum feed. So now we are actually taking around 260 KSM cube of feed. Now here is the cost benefit analysis, and if you can see the cost reduction of consumer gas, it is around 8,75,000, but the revenue generated, it is around 45,76,000. So if I will minus, and the cost of running one FSL pump, so it is coming around 36,98,000 per day, and for stage 2 it is around 15,85,000 per day. So the total gain is around 52 lakhs per day, and if you will convert it for year, it is around 189 CR. So it's a huge amount. Now the second part of our increased production is achieving zero flaring. So what we did, we actually made some teams to study from where the flarings are happening and where we are actually not paying attention to. And you can see Uran plant has 2 flare gas recovery units, but still we were not able to achieve zero flaring. So it's a question for any outsider that if you have 2 flare gas recovery units and still you are not achieving zero flaring, so that's a questionable thing. So we did a study upon it. And another problem that we were facing is FGRU, our flare gas recovery compressor, it was tripping very frequently. Whenever flare load was changing, the tripping of recovery compressor was happening, and we were losing huge quantity of gas into the flare. So first, we actually went step by step. First, we identified all the continuous and intermediate flaring points. I have mentioned some of the flaring points in my PPT, and we actually decided that we will target one flaring point at a time. We will target one flaring point, and we will stop flaring from that point. Then we'll move on to the next point. Here is one example what we did in our plant to stop one continuous as well as you can say intermittent flaring. We did some modification. We actually laid one new line so that whatever liquid is generated or getting collected in this vessel, it will be directed back to the another vessel which can handle it. So like this, 3, 4, 5 modifications were made in the plant so that we can stop any kind of flaring. Now, if I talk about preventing the tripping of our flare gas recovery compressor, so the main problem was there were around 5 to 6 pressure transmitters, and all the pressure transmitters were not giving the same values because they were not calibrated well enough. So we talked with our instrumentation team and engaged OEM also, so that it can give same reading. All 6 pressure transmitters should give same reading. Means if 3 pressure transmitters are used for switches and 1 pressure transmitter was used for loading or unloading, the all pressure transmitters should give same reading. And secondly, earlier it was taking around 1 minute for 7% loading or 7% unloading. So we talked with the OEM and we told that our flare load is very, means you can say very variable. So we need reduction in time. So now it is getting loaded and unloaded in 40 seconds. So with this, we actually reduce the flaring and tripping of our Uran plant. And nowadays we are actually achieving very less flaring. If any flare upsets, or you can say tripping of lean gas compressor or any power fluctuations are not happening, then we are actually achieving zero flaring every day. And the production is also increased considerably. And here is one representation of flare gas recovery compressor. And with this, I would like to conclude my presentation. Thank you so much.
Thanks a lot, Samir. It's a lot of data with a lot of optimization techniques and everything. Thanks a lot for that. Now I would invite Mr. Shashi Shekhar, Assistant Manager from the Indian Oil Corporation.
Respected Srinivas sir, our chair, eminent speakers, and all the delegates, a very good afternoon to all of you. I am Shashi Shekhar. I work for Indian Oil Corporation Private Limited in the Marine Department. I look after tanker operations and SPM maintenance. My profile is a bit different and unique since it allows me to board many crude oil tankers, so I get to see what's happening in the tanker industry. My presentation is on banking on LNG bunkering. I will be discussing all the modalities, the technical modalities, the commercial concerns, the climate concerns, and the business angles. And hopefully your questions will also help me to fill any gap if I have made. The genesis of this presentation actually lies in the fact that the crude oil tankers which we handle at Paradeep and Varinur, few of the crude oil tankers have started using LNG as a fuel. So they have replaced the traditional fuel of HFO and BO. So it is quite pertinent to remain relevant and aware of what's happening in the marine fuel segment. So the presentation will discuss on, is there a need to switch to LNG for fueling the ships, why, when and how, the cost and the climate concerns, the cost of capital involved, the cost of the fuel, the cost of maintenance in the dual fuel engine vis-a-vis the contemporary marine engine. We'll see the break-even point and the offset options. There is always a concern for the ship owner that whether he will get reliable supplies or not if he puts the money to build the ship. So we'll see how that concern has been handled. Then there is always a concern for the oil company whether they are going to get assured sales for the LNG or not if they put up LNG bunkering facility. So we'll see some solutions which can create a symbiosis. We will see the safety aspects involved. There is something called as the concept of home port. We have a joint venture study of Softcom, Float and Shell. This is my personal field experience of the tanker which I boarded, which was having LNG tanks. Then at the end, what is there for the Indian oil companies, the taxation angles, and all the questions which can come. Just to brief the audience, the LNG specifics, it's a liquid gas at minus 160 degrees Celsius. The costing varies. We normally use the Japan Korea marker. It varies from $9 to $10 per MMBTU. Right now, it has even gone to $80, $85 per MMBTU. The gas which we produce in India, that is sold at around 6.5 for the nomination field, and from the other fields, the PNGRB has fixed a price for $7.82 per MMBTU. The LNG bunkers are normally priced by taking the mean of Platts Singapore, which happens for the marine FO and VLSFO as well. Uh, w- the shipping industry is comfortable with the price of around $9 to $10, at max to $15 per MMBTU. It's known to all, just the specific parameters. Uh, as far as LNG bunkering in India is concerned, right now there are very few, or I will say close to none, LNG bunkering facilities in India. It was done by PLL at Kochi on a trial basis. Even it is in this entire South Asia region, only Singapore is having a barge which can put LNG on the ship. As far as the government policy is concerned, they are still evaluating it as a transportation fuel in the inland waterways. There are opportunities for LNG bunkering, which I'll just show in the further slides. As far as the statistics is concerned, there are around 1,000 vessels which are right now being fueled on LNG. Major players are Shell and MOL. As far as the bunkering facilities are concerned, the biggest bunker vessel has got a capacity of around 30,000 cubic meters. Normally, the LNG bunkering vessels or the small tankers, they have a capacity of around 10,000 cubic meters. As per the Platts estimate, the growth is around to 9 MMTPA by 2025 and to 30 by 2030. Right now, Europe is leading with 23 operational ports. Yes, so I come back to the genesis of this presentation. This is a case example of Ocean Sky prospect, which was boarded by me at Varinad somewhere in April last year. So the vessel was having two tanks of 650 cubic meters. The main engine was a low pressure dual fuel engine. So it was consuming around 30 metric ton of LNG in a day in a laden passage. If the tanks are not having LNG, then we inert the system by nitrogen. The gas injection happens at 45 degrees Celsius. It has to be above the engine room temperature and at 12 bar. To send the fuel to the tank, to the engine, there are fuel pumps, quite solid fuel pumps straight inside the LNG tank. But the maneuvering is always done by DO and HFO. The advantage which it gives to the ship is that there is a reduction in the maintenance. There is the decarb of the engine can be taken at 32,000 hours from the 16,000 hours which we do it when we run on VLSFO. There is an elimination of the purifiers. You don't need more purifiers. 2 purifiers are sufficient. Then you don't need to put high base number lube oil. So you can go for the low base number cylinder lube oil as well. So from a marine engineering perspective, yes, LNG does give many convenience to the ships, but there are some other concerns which we will see in the further slides. This is a snap of the vessel. As you can see, there are two LNG tanks straight on the deck. The tanks are the IMO Type C tanks. All the LNG tanks on the ships which are running on LNG, they are IMO Type C only. Only the LNG tankers which carry LNG as a cargo, they are having the membrane type tanks. But the membrane type tanks cannot stand on their own, so this design is preferred. As far as the bunkering modalities are concerned, there are two ways by which we can do the bunkering, either by tank to ship, that is a tank truck to ship, or by ship to ship. This is a second example of the vessel which I boarded last month only. That was a VLCC, brand new VLCC, built this year, built last year, owned by ADNOC. It was having two tanks of 3,000 cubic meters. The main engine consumption is quite low, 35 metric tons of LNG in a day. This gives quite a good endurance. LNG is injected at only when the engine is running at more than 20% of the MCR. It was a high pressure dual fuel engine as compared with the last vessel. Injection is done as 300 bar. For the maneuvering phase, we always use DO and HFO. So in this operation, around 5 metric ton of DO was being used with 35 tons of LNG. The benefits, as I said, the lube oil consumption was less. the decarb hours were increased. This is a snap of the vessel, the VLCC Hapshan. This is the flue gas supply system. Since the tanks are at the pressure of around 4 to 5 bar, so the boil of gas is sent to a boil of compressor, and the liquid which is there is sent to a high pressure pump. Both of them make their way to the main engine after the vaporizer. I'll just zip through it. This is the snap of the main engine. The LNG fuel tank and the LNG feed pumps specifications. The high pressure. This was the flue gas supply system room, FGSS room. The vaporizers. When we talk of LNG, it's very pertinent that we should talk of the emergencies also, which can come while using LNG. So as we can see in this diagram, it's hazardous, but yes, the systems and the technologies are there to keep the hazard under control. We investigate what all can be the emergency scenarios. There can be an LNG leakage from the tank. There can be a fire on ship. There can be an equipment failure. We may need to do emergency unloading of LNG also. So all these factors have been well taken care of in the design. Coming to the pros and cons, as is the case in the marine FO business, there is always a concern for the quality and the quantity. We all know of the cappuccino effect, which at one point of time Singapore was quite notorious. So this kind of concerns are not there with LNG. The facilities are sophisticated and it is mainly owned by the oil company. The sales volumes are fixed for long term by means of JV agreement. The silver lining in this business is that there is a concept of home port, like all the flight, I flew from Bangalore to Goa, so the flight went back to Bangalore. So Bangalore is the base for that flight, so all the maintenance takes care in Bangalore. So if India is able to attract the ships as a home port, then they will give you many other businesses as well. If they start fueling in India, they will start taking lube oils also from India, which as of now, to put it in perspective, all the major crude oil tankers which come to India to offload the crude oil, they all go back to Fujairah to take the fuel. So this shift can be made possible since right now Fujairah is not having any LNG bunkering facilities, so we can go for the early mover advantage. The engine room gets simplified from the engineering point of view. The systems are quite robust. There are some negatives as well, like the bunkering duration. No ships wants to wait for anyone. So it takes around 10 hours to bunker the LNG tanks if they are not at the minus 160 degrees Celsius temperature. But if they are already having LNG inside, then from the conversation which we had with the engineers over there, it will take only 3 to 4 hours. The facilities are limited for LNG bunkering. There is always this chicken and egg problem that the ship owner says that the oil company should make the first move. The oil company says that the ship owner should make the first move. So we need to create a workable solution or a symbiosis in which both of them can sustain. And then the port operation and maneuvering, that is okay, it's a technical condition, it's always done on HSP. There are shortage of LNG barges as well. From my operations point of view, those tanks which I showed on the deck, I'll just go back to that slide. They actually obscure the view. I cannot see the manifold from the CCR because of these tanks. So you need to have a camera at the manifold. Otherwise, in other tankers from the cargo control room, it's very easy to see the CCR. So this is a disadvantage which can be taken care by putting a camera at the manifold. Yes, when we talk of LNG tanks, is there any extra baggage? No, it is not there. I'll just show how it is. Like this is a comparison between two vessels, one which was having the LNG tank and the other which is a normal vessel. The cargo carrying capacity is same. The GRT is also almost same. The NRT is also almost same. So even if you put the LNG tank on the vessel, you don't miss on cargo carrying capacity. There is a marginal increase in the GRT, which can lead to a bit of increase in the port cost, but that can be compensated by the energy advantage or the cost advantage which LNG will give it to you. In this case, this is the latest design of an LNG tanker, that is Hapshan, that is a VLCC. In this, you can see that that for the same cargo carrying capacity, the GRT of Hapshan is less. So, what else do you want? Means you are paying less to the port, you are carrying the same amount of cargo, and if the cost of LNG is at par or in the bracket of VLSFO, it makes sense to go for them. As far as climate complications are concerned, everyone is talking on climate. So the first graph which I have circled, the emissions are the least in case of an LNG, provided it is a high pressure dual fuel engine. As we can see, 657 grams CO2 equivalent per kilowatt hours. So we recently saw that in 2020 the new MARPOL regulations came, in which the sulfur content was reduced from 3.5% to 0.5%. So this climate concerns will give an impetus and will force us or will can be a point where we can think of putting LNG on the ships. This is the common problem. So there is a solution for this. What I have gathered from the vessel. There is a joint venture between Shell and Sovcomflot. The Shell has taken the responsibility to give assured bunkers, LNG bunkers. In in lieu of that assurance, Sovcomflot has agreed to put the capital and build the vessel. Even the port charges of doing the LNG bunkering is taken care by Shell. So it's kind of a win-win relation for both the oil company and the ship company. And in terms of this joint venture, there are 6 vessels which are currently in the seas.
You need to wrap
Yes.
up.
Yes, sir. So what is there for India? We have got a huge and assured long-term captive sales for OMC. And why I say that? Because there are too many oil tankers which bring oil for us. So if they are getting business from us, it makes sense to talk with them to give business to us as well. It will open the non-fuel revenues, home port attractions, obviously. Right now, we don't do HFO bunkering much. Most of it is happening in Singapore and Fujairah, so we should not miss this bus. It also firms up our commitment on the emissions which the government is making. The taxation has to be very conducive, and the LNG pricing policy also needs to be looked into, given the benefits it has if India becomes a home port. And that's all from my side. Thank you.
Thank you. Thanks a lot. I think this comes to the end of the speaker session. So we unfortunately we do not have the fourth speaker available. So we have time. We still have some time for questions. Before we start questions, let me summarize the session a little bit. I think we started well with Ms. Isabella speaking about how the gas market is happening in Brazil and trying to, with the timeline, how it evolved, and finally how it opened the ventures for everybody into the gas market in Brazil. Lot of contributions and that, and how it improved the overall economy of the Brazil itself, which is excellent. And then we have heard about a lot of data from Mr. Samir on how the process optimization can help the entire value chain of the existing plants with limited investments and saving to the tune of, correct me if I'm wrong, maybe close to 200 crores a year, which is a big number. And of course, Mr. Shashi taking away the new concept of LNG bunkering, which is, at least for me, it's relatively unheard of, but he puts a perspective of how it can be comparable And if we want to get something new, we should also be evaluating how it will be replacing the existing one, which is a very good comparison. So thanks a lot, all of the speakers, and it's a privilege for me to just listen to you and hear and learn something from you. Thanks a lot, and we are open for some questions. So there are people who will be distributing the mics, and I request the questioners to please state your name and to whom you are addressing your question so that it's easy for the speakers to answer. Okay, if there are no questions, I think it's a privilege. Thanks a lot. Thank you, everybody. Thanks a lot, speakers.